Hey, Paz, what's up?
Night, sir.
Good night, Benicio.
Night, sir.
Mhm.
Yes, Anne. We almost reached home in our camping, Jesus.
Because I'm going to start in 3 minutes time at 22. So 3 minutes time, I'm going to start. All right, guys. So let us renew our conversation that we last had. I think we were having a beautiful conversation, with the okay. I think it's just Uganda I know here, guys.
Say again, sir.
I think it's just Uganda alone here now. Vinika just left.
Venica still there?
No?
I
Oh,
see her on the screen.
Oh no, maybe she log on from
Yeah,
another.
I would just pass through the dead spot. Oh, I
Okay.
got very traumatic.
Okay, no, I have a notification on my system, so it told me that somebody left. All right, so we're gonna have a conversation. Continue the conversation rather, not to have a conversation. We continue our conversation we had the last time. With the two balls, each containing 100 balls, numbered from 1 to 100, and we recognize that possible outcomes if we were to pick a ball from each bowl. Order is important. So if I pick a 1 and a 10, and then a 10 and a 1 is not the same thing because order is important. So we recognize that we'd have gotten 10,000 opportunities or 10,000 different outcomes. Can you still remember that conversation?
Yes, sir. You said 10,000
Yes, sir.
chances?
Right, 10,000 chances, right. So you still remember that conversation?
Yes, sir.
All right, good. So we're gonna improve on that conversation now. So now if I let E be the event, if I'm naming the event and I call E to be the event, that two balls add up to 201. What outcomes of the element we have? If I call the event E, just like what you name Venica, just like what you name Paz, if I call the event E, and I say that that event has two balls that add up to 201, how many outcomes will I have for that?
So the event is E, and you have
Yeah, I'm just naming the event. I'm just calling the event. Yeah, I could call it anything.
right,
But I'm
sir.
right. And I have two balls. I'm asking what would be the probability of me selecting two balls that add up to 201?
Uh, 201?
Mm-hmm.
0?
Why?
Why 0?
Mm-hmm.
Because 100 ball from 1 to 100 in each bowl.
Mm-hmm.
And so each bowl have been 100. So if it's two ball with 100, it will give us 200, but not 201.
Okay, good. So very good. So I asked a question sarcastically because I wanted to hear your reason. Yeah. So there is no outcome in which we can add up to 201. So that event is going to be equal to the null set.
Oh.
That event can't be equal at all. There is no event that can take place. You get that, Paz?
Yes, sir.
Come
Even
fake
because mute Veronica, right? Because the event is in such a way that the balls are numbered 1 to 100 in each bowl. So there's no combination of balls I can get that can add up to 201. Can I have something that can add up to 99? How many events do I have that can add up to 199?
Sir, 2?
And
No.
name them.
1.
Oh, sir. 99, wait, 98 and 1.
No. Hold on. I said
No,
199. 199.
199.
199. Well, I hear you say one and I hear Mikey say two.
2.
But I want it to be 199. Tell me how I can get that.
199. Well, I can get it several ways.
How can I get 199? How many events do I have? Go back to what it is that you're thinking, Benika. I said
Hold on.
if I again like E with the event, that 2 balls add up to 199. What are the outcomes of event of the element E? What would I have? How many of those outcomes will I have?
There wouldn't it be one?
And name it the event. Which event? You said
One.
one. So name it.
Oh, 199. So 100 in one hand and 99 in the other.
Okay.
Oh, two, liar, two.
Okay. Thank you,
99
ma'am.
and 100 and 199.
Thank you very much. That's why I asked the question. So you said
Yes.
one, Maggie said two. I said, okay, we must get an answer out of this. Yes, because remember I said order is important, don't?
Order, right.
Yeah. So me select 100 in the left hand and 99 in the right hand is not the same as me reversing it. It's two different events. You follow me? Yeah,
Yes,
man.
sir.
Yeah. So it's going to be that. All right. So I'm going through this because I really want you guys to get it. I really want you guys to get it. That's why I'm going through this stuff. All right. So, hold on 1 minute, please. All right. So I think you guys are getting there. So the examples that I've given you illustrate the idea of the one with the 201, when we say that it can't happen, illustrates the idea that we have an impossible event. It illustrates an idea that it has an impossible event. Now, let me tell you what a real life impossible event for me, my life, that I can know for sure 100% that I will never die from is bungee jumping, is riding on a motorcycle, is bailing off our bus. I can tell you I will never die that way. Why? Are you hearing me, guys?
So I heard
Sir, what you said?
motorcycle and then it chip out.
Sir, those are impossible events that you will never participate in.
Those are
Okay.
impossible events. It will never happen because I will never participate in them. So that's why those events are known as impossible events.
Sir, you leave out live on one hillside.
Talk truth. Talk truth. And make it matters worse. There is erosion and taking place at the foot of the hill. And I don't care if I get it free of cost with groceries every day. It just won't happen. But I don't know if my internet is stable. Are you hearing me though?
Yeah, man, I hear you clear.
Oh, okay. Yeah. So those are some impossible events. When I say impossible events, right? So getting something for 201, 202, 3, 4, 5, whatever, those are impossible events. No, an event which contains no outcome is known as an impossible event. An event that has absolutely no outcomes is an impossible event. Now, in contrast, a certain event is going to be an event that contains all possible outcomes. A certain event is going to be that event that contains all possible outcomes. And I'm going to give you an example. But before I give you the example, something is clogging my mind. And as I speak about some impossible events, I want to caution you on some of them. So I saw something on social media, well, actually not on social media. Somebody sent me a video of a gentleman who was in a fiery crash along the PJ Patterson Highway.
Oh, I saw it as well, sir.
Oh my goodness gracious. And the thought came to mind that it looks like it's about 90% of his body that got burned. That's what I said to myself when I saw it, I was like, wow, the man is fully burned. And then I thought to myself, oh, he will live. And today I'm hearing on the news that, well, some medical facilities don't want to take him because he's too far gone. Now, I'm looking at it. I mean, I heard it on what would have been the 6 o'clock news, and it has been right in my spirit because I'm saying to myself, how can a medical facility say that they're not going to take you? The family would have to sign a disclosure that they are going to do the very best. So in the event that something goes wrong, they can sue me. So I say, as opposed to just saying, we're not going to take you. So more than likely, one of the hospital that he's in now, they're saying that he's stabilized. That's the most they can do for him because he's so far gone. And I'm saying the skin is an organ, is the largest organ we have. And when that organ is removed, we are susceptible for infections. And that infection, I mean, when I say infection, the mere wind that blows on you, the wind that blows, carry dust with it, don't?
Full of pollutant.
Yeah, man. So you see why I have a problem I eat on street side? Street side and on my base, I care what them want to say. Because especially if you have, well, if a stray dog and puss, and when them lego them something, and them dry and turn stone. You ever play with a friend and see how you take stone off a friend and when you check us up on a stone or something else?
Yeah, that happened already.
Oh,
Yes, yes, I. So just imagine now, you are cook one nice piece of curry go to the door and puff a wind come and say, no, not now kill you. And then after that, no, me recognize when me eating or negative. That's why I don't eat a roadside. So just imagine that gentleman now is exposed to that puff of wind. It's a lot of, the air is not clean. So he will have to be now in a sterile environment. And, oh Lord. So, I don't know, it just, and it's an accident he was, well, the news was saying that he was trying to prevent from happening, and swerved and, got, the fire got out of control and hit a metal post and it was engulfed in fire. I say this to say to you, as it is right in my headspace, please be careful, guys. Please be careful. I'm saying it to you as I'm saying it to myself. Please be careful. If you go late, I better you turn back or just condition your mind so you go late. Now try beat it because you may never reach. Aye. But anyhow, let's go. So that's one of the events that I can tell you won't happen to me in terms of, I mean, accidents can happen. That's a certain event. A certain event is that you will always have motor vehicle accidents. But in terms of driving fast, like there's no tomorrow, that is impossible for me. I will stop the car and I'll give you a way to go. And I've done it before. I put my hand through the window and I signal to overtake me. And while they overtake me, they told me how much my mother loves me and what I'm supposed to go and do with her. And I take it with a smile because that is going to be an impossible event for me. Nope, not going to happen. So, an impossible event, remember, contains no possible outcomes. No possible outcomes. right? No possible outcomes. And then in contrast, or a certain event is an event that is going to include all the possible outcomes. Does that make sense?
Yes, sir.
Yes.
All right.
Yes, sir.
All right. And this I know you would have read through on Edico, but I'm just going to go through some stuff with you before we get into some calculations. And I want to feel out your headspace. Now I'm going to move into another little thingy, Bob. Suppose I flip a coin 3 times. The event that we obtain at least one head or one tail, is that a certain event or an impossible event? Let me read it. Let me ask the question again. If I flip a coin 3 times, let me answer the question. Let me pause. If I flip a coin 3 times, what is my sample space? I flip a coin 3 times. What's my sample space?
Head or tails?
Yeah, but how many possible events do I get?
Two.
Eight.
Two.
What?
To be events are 8.
8
Yeah.
of them.
So what you call the 2 flips? I think we forgetting the terms.
And that's why I'm having a conversation with you. So my sample space is going to be the set of all possible outcomes. And an event is a subset of the sample space. You follow me?
So it says that the sample space
It's
is
all
all
the
possible results.
Yes. And an event is something that occurs within that sample space. So the event of me, you remember I said to you earlier, let E be the event that 2 balls add up to 201.
Right, sir.
Right. So the event is going to be a subset of the sample space. So an event is like something occurring, but does it fit into the sample space? The sample space is telling you what the all possible outcomes. The event is going to be a subset of it. So you will always find the event within the sample space if it is possible. You follow me? The impossible event will not be contained in the sample space because it will never exist. Hello?
All right. So just to get a better understanding, so the sample space would be, as you say, all the possible outcomes. So that's 3 times flipping the coin, which has 2 sides. So what you call the two sides is called the event.
Very good. Very good.
Oh, yes.
So the event of getting a head or the event of getting a tail. But what would be the sample space of flipping all 3 coins? Say 8.
Right, sir.
8, yeah.
Yeah, I get it, sir. 8.
Right. Okay. So now that we have the stuff. So good. So if I flip 3 coins 3 times, if I flip a coin 3 times, the event that we obtain at least one head or one tail is going to be certain. It's going to be certain because we know when we looked at the stuff, we can get either one head or one tail. True or false?
True, sir.
True.
Aha. So let me ask you this question before I move into it. I did some of this video the other day, but you didn't know what it is that I was doing. What is the probability of me flipping a coin 3 times and not getting a tail?
One. Because there's only one head. One triple head.
Anybody else? All right. Okay. So we're gonna hold on to that. Mute Venica. We're gonna hold on to that. We're gonna hold on to that for now, and then I'm gonna come back to you, Mikey. I like your results. I like your contribution though. Love it.
I feel like I'm wrong, you know.
No, I am not saying a thing to you. You could be wrong, you could be right. I am saying nothing. But let me move into this. So we're going to consider the probability of an event. All right. No,
You're not sharing anything, sir.
huh?
You're not sharing anything.
I know it's a conversation I'm having with you, but I don't start giving the questions yet. So I want to have that conversation with you. So let us have the probability of an event. Now, an impossible event has a probability of what? An impossible event has a probability of what?
0.
Zero. Very good. I want the rest of you to come in because Venica wants to she wants sharp, All right. So the probability of an impossible event is 0. What is the probability of a certain event?
It always have an outcome.
Which is?
Oh, well,
certain-
1 to the
I hate
is a certain event again?
Um, what is the hold on 1 minute, please. All right. So I asked the question, what is the probability of an impossible event? And your response is?
0.
0.
No.
What is the probability of a certain event?
Well, 1.
Is it
Why
1 to the possible outcome?
Why is it 1 pass?
Sir,
Must happen. It must happen. There must be an outcome.
Yeah?
There must be an outcome. It must happen. It is
Well,
possible.
yeah, if it is a certain event, yeah. If it's a certain event, it must happen. But what I'm saying, what is the probability? Paz was saying 1. Why is it 1 pass?
sir, I'm not certain, but I just know it's 1.
You're not certain, but you know it's 1.
Yeah.
Did I teach you anything until I told you that before? Did we
No, sir.
excuse me? Did we
No,
previously look at probability distribution?
yeah, we looked at it last class.
And not the last class. We did probability distribution before we did correlation coefficient.
Mm-hmm.
Yeah, man. I remember I gave it the double integral, not integral, I'm sorry. Inequality to read. What is the
Yeah.
probability of x?
Sir, it must
Greater
equal
than-
to 1. Can greater than 1.
Y. Okay, so Mikey's remembering now. Why can it not be greater than 1? Because the sum
Is
of
equal.
Of all probabilities equal 1.
Is equal to 1.
Right.
Oh, yes. I remember, sir.
Yeah, man. So the probability of a certain event is going to be equals to 1. The probability of an impossible event is going to be equals to 0. Now, put it this way. I know It is an impossible event for me to eat alligator tail. It is impossible. I don't care how you say that. It is a delicacy, and how this is what the American people them eating. That's their business.
Unless we trick you.
And
You know,
guess
just
what?
about to say that. Suppose you
And
don't
guess
know.
what? The truth is, I'm very particular. I'm very, very, very particular. I remember when they had the whole business about using horse meat. Anybody remember that era? They're selling horse meat as
For beef.
for beef. All right, Venica remembers. Yeah. My wife and I went to. She accompanied me to a math conference. You see, and we were going to buy food. I mean, food to cook. We're at Airbnb. Food to cook. And both of us stood up in the supermarket and we said, okay, let us agree that we're not eating any beef because we don't know where it come from. And the agreement was yes. And we also agreed that we're going to buy chicken. But whatever part of the chicken that we are purchasing, we should be able to identify it. So guess what? I won't go in there and go buy no drumsticks because I don't know if it's frog's legs. So I ain't going to buy that. So I'm going to buy a piece of the chicken. Go ahead.
So you buy a whole of chicken?
No, I bought it in parts, but I was able to identify, and I know with a shadow of a doubt that this was chicken. You understand? So all I can say to you, Mikey, I'm particular. Because you see, when you go and you get them little Chinese food and you see, you buy special something and you see, only thing mix up in something, I don't want it. Because I'm very particular. But one of the other things though, a certain event is, if I don't eat food, I'll die. So that's another event that you know is certain. And what is the probability of me dying if I don't eat food is 1, because it's a certain event for it to happen. Right? Very certain. That's the point I'm making. Now, between 0 and 1, there are countless possibilities. So the interesting part of probability is not at the extreme, not the impossible event and the possible event. What is interesting about probability are the events that occur between the impossible and the possible. Does that make sense?
Repeat.
Yes.
Now I'm just saying to you, what is interesting is not the impossible event or the possible event, the certain event or the impossible event. Because we know that the probability of the certain event is going to be 1, and the probability of the impossible event is 0. So I am not really interested in the extreme, the 0 and the 1. The real meat and the interesting thing comes from what happens between 0 and 1. The different probabilities that will take place between 0 and 1. So that is what is important. Make sense?
Yeah.
Okay. So as a result of that now, I will say that the probability of an event occurring is going to be the event over the sample. Does that make sense?
Yes,
And
sir.
then, right. And then
The sample
Venica,
space.
yeah, right. The sample space. And Venica don't want to answer, Paza don't want to answer. I'm going to go back to Mikey's stuff. I told you I was going to come back to you, Mikey. Let me say this now again. The probability of an event occurring, and I'm going to write that equation. The probability of an event occurring is going to be the event itself occurring over the sample size. So let me bring this thing up and share my screen. Yes, Mikey, I'm coming back to you. And you don't need to get worried, because it's not that serious. It's not that serious. I just wanted to come on. Control N. On share screen. All right. All right. So what I'm saying to you, let me know if you're seeing the screen, are you?
Yes, sir.
Yes, sir.
All right. So what I'm saying to you is the probability of an event E, probability of an event E the probability of an event E is the number of outcomes in E divided by the number of outcomes in S. So the probability of an event E occurring is going to be the number of outcomes in E over the number of outcomes in S. You remember the question I asked you, Mikey, originally?
Yes, sir.
What was the question?
What is the probability that
You don't get a tail.
you don't get a tail?
And what's your answer now? How many
Sir,
outcomes?
mine still I say one, you know.
Okay, all right. Paz, what say you?
0.
Vanika, please help them.
1/8.
Did you hear what she said, guys?
1 out of 8.
Mm-hmm.
But sorry, you didn't do that
Oh,
last
because the
week.
outcome would have been 8. You have 8 outcomes.
Very good.
Mhm.
So, but if I did it last, week, Mikey, oh, you're not giving me the answer.
No, but
No, but you see, remember, no. All right. Let
sir,
us
I realize that you didn't ask, you know, honest to God.
no, let us dissect the thing. And this has nothing to do with me thinking that you're not a smart guy, because that's not the truth, right? But let us dissect the response we got. What is the probability of me tossing one coin 3 times and not getting a tail? And you're saying 1. Is that
Yeah, incomplete. Yeah, I
the
understand.
only event? Is that the only event in that sample?
No.
No, it's not. It's not. And that's
Yeah,
what we need to look at. Right. So the probability of an event E occurring is going to be the number of outcomes of that event E over the number of outcome in the sample. In the sample. So remember, Vanika just asked a while ago, sir, let me know. Sample event? Yes. So remember, no, the event is a subset of the sample. So therefore, it is not just going to be 1. It is going to be 1/8. That is a probability. It's going to be 1/8. Let me ask the question another way around. What is the probability of me getting 4 heads?
0/8.
which is
4 heads.
Null.
which is 0, right? So it's an
0.
impossible event. Why is it impossible?
Because you'll have 3.
Because I'm
coins.
tossing the coin 3
Three
times,
times.
unless the coin is not a fair coin.
Yeah.
Unless the coin is not a fair coin, unless the coin has one of the coins has 2 heads. You follow me? So the coin has, if it is not a fair coin and one of the coin has 2 heads, then I could get a possibility where I toss it 3 times and I get 4 heads. Because one of the heads going to be 2 and the other 2 coins going to be 1 each. So that's why when you see your questions you say a fair coin is tossed. And we say a fair coin because it means that there is nothing to it. All right. So that's why we say a fair coin is tossed. Because when a fair coin is tossed, it means that I don't have 2 heads and I don't have 2 tails. Case in point. You know, sometimes when in football, in international competitions, or otherwise too, not just international competitions, when a team doesn't want to go first, and say, okay, let's flip the coin, and they say, what do you want? And then they tell you what it is that you want. They have a coin. If you say heads, they have a coin that sometimes is not a fair coin. So you're saying that you're selecting heads because whoever wins is a cricket match. Whoever wins bat first. But I know that I don't want to bat first. I want to field first. So if I'm tossing a coin, chances are we may use a coin that is not fair, a coin that has 2 tails. So wherever you flip the coin, you're going to get the tail. So you will end up winning. So which is why oftentimes before the coin is flipped, you see the referee looking at the coin to make sure that the coin is fair. If you never take notes of that, when you're watching them FIFA matches, look at it and see what it is that they do. They make sure that look at the coin to ensure that the coin is a fair coin, so that no team gets that unfair advantage. All right. So just remember the formulation that is on screen. The probability of an event is going to be the number of outcomes in that event over the number of outcomes in the sample space. Am I clear right there?
Yes, sir.
All right. Paz, how you stay?
Yes, sir.
All right. I know Venica catch it, you know. All right. So I am trying to. So remember now that. So the probability of an event is really going to be the proportion of the outcomes in the sample space that are also the outcomes in an event, right? So remember now, 1 is going to be a subset. Remember, the event is a subset of my sample space. All right. I am going to give you something now. I'm going to read something for you. Matter of fact, let me type it. And I want to all right. So here's my question. Imagine You flip a fair coin. See the word fair there again? With two possible outcomes, a head or a tail. Oh, you can't answer the thing?
Not all of it.
Not all of it. Yeah.
The probability that I get 1T. That's better.
Okay. So imagine flip a coin with two possibilities, the head or the tail. What is the probability that you will get one tail if I flip the coin once? What if I flip the coin 3 times? Take 2 minutes to read the question and think about it. I'm going to mute. 2 minutes to do that. All right, tell me now, guys.
So,
Uh-huh.
so for the one time, 1/2 because the space
Mm-hmm.
would be 2.
Mm-hmm.
No lie. Yeah, the space would be 2. So I have 1/2, and for the other one I have 1/8. Because it would be the 2 to the third power. So I have 1/8. If you flip it 3 times.
Think about it a second. Think about it a second. Yeah. Okay, yes, Mikey, go ahead.
All right. So I have for the first flip, it's one flip, one event. So I have 1/1.
Mm.
And for the second part, I have 2/8.
Sir, for the first one, I have 1/2.
Uh-huh.
And for the third one,
Third, which third?
no man, when they say what if I flip it 3 times?
Okay, yeah, but another, go ahead.
Yeah.
The second one, you have what?
But because it's 2 outcomes, it's 2 events, I don't think that one would have make sense.
You don't think it would make sense?
Yeah, like it would have been
But
like
a
0 out of 2.
But if it's what's the probability that I get exactly 1T? But even if you flip it 3 times, there's a possibility that you can get 1T. You
So
get 2
therefore,
head and 1T.
so what are you saying? What's your point? Your
So
point
I was
is?
saying 1/8.
Uh-huh. No, but you're contradicting yourself. You just said one something a while ago, and then you're saying something else. No, you're contradicting yourself. Come, continue the conversation, Benika.
Sir, so I was thinking when the 8 comes in is because you flip it 3 times.
Mm-hmm.
and the wait, the all possible outcomes. Because if you flip the coin have two sides, you flip it 3 times. I'm thinking about the sample space would be 8. But then when I'm thinking about the probability of getting 1 T, and you said that the certain probability is equal to 1, it's no greater than 1. So that's I put it 1/8. But if it's about the order, because now I'm looking differently now. If about the order, does the order affect this calculation? Because the T can come different place during the 3 flips.
All right, so 2 questions. What is the T
Question
coming different
3.
places?
It could come tail, head, head, tail, head, head, tail. So is it at your times the probability is it at your times the sample event by 3? Because
so what is it?
What 3/8? Would it be 3/8?
So you're saying it's 3/8. All right. I won't answer you just yet, but I like your reasoning, and that's why I was pressing. So let us read the question again. Imagine I flip a fair coin, and I said fair, and I explain what fair means. It has 1 head, it has 1 tail. And it is also fair that it is going to be flat on both sides, so that it doesn't, when you flip it, it don't automatically drop on one side. And it's going to be fair that one side is not going to be heavier than the other side. You know what I mean? It's just fair. The possibility is going to be 50-50. With 2 possible outcomes, heads or tails. What is the probability that I get exactly 1 T if I flip the coin once? What if I flip the coin 3 times? Did the question say that to get a T at the first flip?
No.
So
No,
Benika,
sir.
yeah, so Benika, why ask me if it's the first flip? All right. So I agree with you. In the first event, I can get a head or I can get a tail. And the question asks me to get exactly 1 tail. To get exactly 1 tail, it is therefore going to be equal to 1/2. The probability of the event occurring, the probability of this event occurring is going to be equal to 1/2, because the number of events in this is 1, and the outcome is 2 possibilities. All right. Now let us look at the second one. You can get a head, a head, a head, a head, a head, a tail, a head, a tail, a head, a tail, a head, a head. Good so far?
Yes, sir.
4/8.
Yes,
You
sir.
can get a tail, a tail, a tail. You can get a tail, a tail, a head. You can get a tail, a head, a tail, or you can get a head, a tail, a tail. Does this represent my 8 possible outcomes?
Yes, sir.
Then the question says, what is the probability of getting exactly 1 T? This one has 1 T, the head, the tail. This one has 1 T, the head, the tail, the head. This one also has 1 T, the tail, the head. All others have 2 T's. So therefore, the probability of this event occurring is going to be 3/8. 3 possibilities over the total of 8.
So, sir, all right. So
Before you go, what the mistake you were doing was reading the question to read on the first try. That's a different question. That's a different question.
Sir, for the first one, I did have the half, you know, the 1/2.
No. I'm not talking about that. I'm not talking about that. Everybody got the half. Everybody got the half. Away from Michael. Michael said 1/1. If I remember, right?
Yeah.
But I'm not talking about that. What I'm talking about is the second part. When you said to me that on the first try, and then I said, read the question. The question about tell you about getting a tail on the first try.
Oh, yeah. Then I did go to the tree.
Right.
Yes.
Right. So it didn't say the tail on the first try. It says just getting exactly one tail
Until in the sequence.
in the sequence. And remember, guys, order is important.
Order.
So,
Mhm.
and I'm going to tell you how order is important. If you have 3 kids or 2, you can't call the second born your firstborn. Well, you can try it, but don't try it in first or the firstborn, because the firstborn will have you up. So the firstborn always has that pride to say, I am the firstborn. And guess what? The wash belly will always have the pride to say, guess what? You can go on. Me get away with murder. You never get away with nothing. Right? So the order is important, because I said to you the last class, if you have a pair of twins, whoever comes out first is going to proudly say to you that I'm the older of the 2, or the older of the 3 or 4 or 5 or 6. They're going to tell you, because it makes a difference. You can't talk to me. I'm supposed to get this because I'm bigger. You know those level of sibling rivalry?
Right,
Yeah.
control.
So I'm saying to you, order is important. You can't tell the head, the tail, say, chop. Never call you the head, the tail, the head. No. Order is important. So it makes a big difference. All right. So that's one of the things that I want you to think about. Okay. Mikey, catch it now?
Yes, sir. I just needed a reason it out wrong.
Fair enough.
Because, all right, so for the first flip, how I reasoned it was how Venica was reasoning the second part.
Mm-hmm.
That's why I just say 1/1.
Mm-hmm. Fair enough.
But I realized that the event is actually the flips,
Mm-hmm.
and it's basically the subset of the head or the tail.
All right. Fair enough. I like that. I like that level of reasoning. I'm going to give you the scenario I gave last class. The scenario I gave the last class. Suppose I have 2 balls, each containing 100 balls, numbered 1 through 100. I pick a ball at random from each ball and look at the numbers on them. What is the probability that the numbers add up to 200? We did part of this question already, you know.
I think I won because
1 out of 10,000.
Very good. Excellent. You see how quickly you get it out of the back? 1/10,000. Because we know that the sample size is 10,000. Remember, we calculated that before?
oh yeah.
Right. So the sample size is 10,000. The sample size is, oh Lord. The sample size is 10,000. Let me just add. Okay, the sample size is 10,000. And how we got 10,000 is going to be 100 square. We're going to get 10,000. Now, the only combination in that we're going to have, you remember what I said to you, we have 1 and 1, then we're going to have 1 and 2, and then we're going to go down until we reach 1 and 100. Talk truth.
Yes, sir.
Then we're going to have 2 and 1, then we're going to have 2 and 2, and we're going to go all the way down until we reach 2 and 100. And we go all the way down until we reach 101, until we reach 102, and then go all the way down until we reach 100, 100. So I'm saying to you, one way of looking at it is this length going down is 100 times, and the length going across here is also 100 times. Now, if in liquor school math, when you're calculating one of those shapes and you get 100 one side and 100 the other side, all you have to do is find the area. And what is the area? Now, 100 times 100, that's my 100 square. And that's how I get my 10,000. But there's only one combination that will give me 200. One combination that will give me 200, and is this. So the probability of that event occurring is going to be 1 over 10,000. Does that make sense?
Yep.
Yes, sir. Mhm.
All right. I have an exercise for you. Should I? Yes, let me give it to you, and I'm going to see how well you work at it. Let me give it to you, and I'm going to see how well you work at it. So let E be the event that the number of balls in the previous example add up to exactly 51. What is the probability of E? Now, you have to go work this out. It's supposed to add up to exactly 51. I give you 5 minutes.
So you have a shortcut on the calculator you can use.
I eat more friend too.
No such luck. And even so, I want you to use your brain cells on this one. Figure it out.
196.
Is that the mind of the 196? How many balls do we have in total? Think about that response.
Sir,
Think about that response.
sir,
Mikey,
hold on.
Mikey,
Hold on.
Mikey, I think the cold just got to your brain a while ago.
It called bad to this today, but let me see if
196? How many balls we have in total? Not 200.
200 balls.
Sir, look at it again, please. And tell me.
hold on, sir. It says E, which is the event, right?
Yeah, man, read it, man. They write this, so read it. Tell me 196.
Let E be the event that the numbers of the balls in the previous example add up to 51. To exactly 51. What's the probability of E?
And the answer is?
Sorry, the event, the sample is still 10,000.
You're saying that is 196?
Over 10,000.
So you're now saying to me now that it's 196 over 10,000. What was your response before when I asked you the question? You said 196, right?
Yeah.
Mm-hmm. Okay. Paz, where are you?
51 over the 10,000.
You get 51 over 10,000? Venika, where are you?
I'm there with myself. I try to work this thing out. But may I work it because even if I work it out, it must equal to. I'm here thinking about the 51 over the 10,000, but my try to work it out same way.
Mm-hmm. You know? Let me give that drum start. Let me give that drum start. In order for the balls to add up to 51, one of the balls must be what?
1.
Very good.
One.
And the other ball is?
50.
50.
So one is 150. Can you have
So you know, if you're true, make I show you something, sir. Because I there so you know with my math self and I see a pattern. I see when I make because I doing it by one. 51 minus 1, 51 minus 2, and there's the pattern. So
okay.
it's going down by 1. So I have the 49, the 2, the 2, the 49, the 48, the 3, the 3, the 48.
Very good. So let us move to that now. So we have the 2 to the 49. Don't.
Yes, sir.
And then we have the what?
The 3 to the 48.
And then the 4 to the
4 to the
47.
47. Yes.
Okay.
And then I
Okay.
do it the other way because the order.
And right, the 50 to the 1. Right. So
Right.
so now that I give that little drum start, Mikey, so what we're saying here now, it says the sum adds up to 51. So there are several possibilities right here. So see if we can come up with it now. How many of them you think we have?
50.
Huh?
Out.
Sir.
50 out of 10,000.
50% doesn't be correct.
50 out of 10,000.
Mm-hmm.
All right, sir. You know what I'm gonna do tonight, sir?
No, don't
Right.
tell me you're gonna write it out. Don't tell me you're gonna write it out. I don't want to hear that.
That me I gonna do tonight, sir.
I don't want to hear you gonna write it out. Think of a way. And the thing about it is that I showed you something the other day now. Think of a way. All right, do me a favor. Do me a favor. You see this first line up here, so? You see this first line up here, so? Tell me how many ways you can get the sum of 51 out of this first line. Just write it down. Don't tell me no. Write it down and tell me how many ways you can get 51, the sum of 51 out of this line. Matter of fact, tell me no. How many ways you can get 51 out of this line?
One time.
One time?
Yeah.
Do you agree with that? The rest of you agree with that?
51 out of the first line.
No. How many times can you get 50? Yeah, how many times can you get the sum of 51 out of the first one?
One.
One time?
I can't one time.
Yeah, man. 150.
150.
Because remember, everything
Hold on, let me last now.
no,
Oh,
man. Remember, each of the X value inside here says one, you know.
51.
we just as the way I
Is that
say
sum? Is the sum of 51?
It's the sum of 51, yeah. But remember, you know,
I want to
remember-
beat myself.
but you remember, you know, every number, every first number in this is one.
Yeah. So if you go down the line, you basically have two, you can count back.
Oh, you mean that first stanza of say one and what?
Right.
Oh,
And then in
oh,
this, and then in the second line now, how many sum of 50 we can get out of that?
You don't get the 49 and 2.
We can't get any more. We can't get any more out of it.
Jesus, I eat. No.
We can't get no more out of that, don't.
No.
And then in the third line, how much where we can get? No, the 3 out of 43 and 48.
Yeah.
48.
And then in the fourth line, how much you get?
447.
47. But I probably made it right to the other way, but me I did it now a long way. But I see the drift.
Yeah,
Yes, it is.
just I see it, I want to beat myself. Literally want to beat myself.
Okay. So yes, so those are some of the things that we need to look at when we are calculating. So yes, it's going to be 50 over 10,000.
Because when you reach 50, you only can get 50 and 1.
Yes.
And then it's done right there.
So
So
that's why, yeah.
Right. You see what I'm saying? When you reach 50 and 1, it's done right there. So
Right.
you
now,
can't move 51 to 1, don't. Because it's going to be halfway. So there are 100 different we call it. What I'm saying to you is when you reach 50, 1, it will be the same as 1, 50. Talk truth.
Yeah.
Because we're not looking at the probability now, we're looking at the sum.
Mm-hmm.
Venika, don't say that yet.
Yeah, that's why I said I want to beat myself.
Venika, you
yes,
see,
I see it now.
yeah,
I
man.
see it because how I was doing it long ways. I didn't write 1 to I didn't write 1 to 50 and going across because then I would have seen the pattern, but I was doing it 1 to 50, 50 to 1, going down in a straight line. But then I realized the 48, I go with the 3, and the 47, I go with the 4. So I realized but I was still writing. Never see that.
Right, don't worry about it. Don't worry about it. All right. So we have 9 minutes, and I want you to figure out this. The banking system in Jamaica, well, internationally, you know, your PIN is really a 4-digit number. All right? Do me a favor. Take 5 minutes to look at this, and we're going to have a 4-minute conversation before the end of the class. All right. My question to you, what is the sample space for this question?
The sample space I have is 10,000.
Excellent. And how did you get the 10,000?
So I have 10 digits and I have 4 chances to
Good
pick
job.
the
So
digit.
therefore you're gonna
10
say
to the 4th power.
10 to the 4th power. Excellent. 10,000. That's my sample space. All right. Excellent. Now it says, what is the probability that my pin contains 4 different digits? Figure out that yet?
So that's the one now I'm here worried about. Because I'm wondering if it's just one. But
I want combination you can get.
no.
Okay, so tell me the combinations you can get.
That one I don't feel it.
Mikey, you agree with the 10,000?
Yes, sir.
Has you agree with the 10,000?
Yes, sir.
All right, come. We're figuring it out. I'll give you 2 more minutes to look at it independently, and we'll talk about it.
I said I want it.
Yeah, that was that kind of.
Because me I think about one.
All right, do me a favor.
I think about 10.
I want you to reason the question out, and we're gonna leave it there until next class. We're gonna leave it there until next class. But guess what? I want you to reason the question out. Is it just like what I reasoned out the other one with you? There is a sequence to the madness, you know. There's a sequence to the madness. But reason it out. If you catch it before, drop it in the WhatsApp group, and I can tell if you're right or wrong. But I don't want to tell you, because if I tell you, you guys not going to be able to see these things through on your own. And I want you to be able to see through on your own. So I'm going to end here. You're going to try to figure out that. Very good, Venica, to figure out the sample size. So now we want the probability of my pin combination. What is it? Pin contains 4 different digits. What is the probability of my pin containing 4 different digits? Go figure.
256.
Huh?
256.
I don't think so. I don't think so. As a matter of fact, you know what? I'm going to give you.
Yes, sir.
You're going to finish. No, hell no. I'm not going to help you there. You're going to finish that. You're going to finish that one, and I'm going to give you one to think about for me. Oh no! What did I do? All right, hold on. I want to have sample SPACE, but I want to give. I'm going to send this. I'm going to send this document I have another question here.
Not 10 over 10,000.
No, sir. This is
A whole heap of different digits can come from that, you know.
I know, but you have to figure out a madness to get it. You have to figure out a madness to get it. And then I'll give you one for homework. Oh, no, come a class next week, God's willing, you know. Without them something I'm saying, because I'm building. The thing about it now, what I'm supposed to move into is a probability distribution. And I've already done probability distribution for it with you. So I can just give you 1 or 2 questions to remind you what it is. but we did the probability distribution already, right? So we're steadily moving along. But
Hold on, there's 000, 111. Come on, there's something to this. We have to figure it out.
it can't just be 000, it have to be 0001 because it's 4 digits.
Oh, Jesus, that's true.
All right. Have a wonderful rest of the evening. I'm gonna don't move yet. Let me make sure that I send this thing off to you first because I have.
So you remember if you did my thing?
Yeah, man. I remember it, man. It's just that I'm prepared for a vetting session tomorrow. But I remember the stuff. You said that the second draft of the timetable has this stuff on it now, Mikey?
Oh, let me check. Let me check right now as well.
No, it's there, man. I saw it. And thanks for telling me because I was able to send them a message. So I sending you to 13204. Because sound like she not gonna sleep tonight in the car. She gotta figure out this.
I catch this tonight.
I see exactly what is happening. All right, I'm sending you. This is business card. I'm sending you the what it is that we're working tonight. ENVIR. Sending you what it is that we work on tonight.
Environmental statistics is Thursday the 9th
Yes.
at 1 o'clock. I hope them send the exam them on time this time, you know, sir.
You have to send it on time. I'm gonna ensure that it is.
The last time when project management done, me just get the exam.
Oh no, Osh. Check to see if we get the WhatsApp of what we did.
Yep.
All right. Are you that?
It have to be 4 different digits. Lord God, I can't go my bed.
Benny can I let it go to shake it.
I had to get this tonight, man.
Have a wonderful evening.
All right, sir.
Later.
Hold on, sir. Hold on, sir. Don't move it. 4
10.
over 10,000. No,
4.
that'll give me a something. So it could have been 10,000 over 4.
10,000 over 4.
10,000 over 4. The sample size can be the event can be more than the sample size.
So wait, sir. So the sample size is the event is 10,000. And we're supposed to find the sample size of 4 digits, 4 different numbers.
Have a good night. Later. Bye.
0, 3, 0, 2, 3, 4, 0, 3.
So basically, sir, you'd have like
0, 3, 4, 5.
0 to 9, 0 to 9, 0 to 9, 4 times.
What?
Right,
I want the probability. So you go tell me the probability.
No, that's why I know if that's how you'd lay it out.
0, 1, 2, 3.
I could lay it out like
1,
that, yeah.
2, 3, 4.
One hint and then I press gone. One hint and then I press gone. The hint is if you look at, it's like what we did with the other question. We look at the first row and then we see, yes, do something like that and you should be fine.
0, 1, 2, 3.
Remember, you know, the first set of number can start with 0.
Right.
The second set of numbers start with
1,
One.
1. The third set of numbers start with
2,
then 3, then
3,
4,
4,
then
5.
have
Yeah.
a good evening. Bye-bye.
All right.
You know catch it later.
Yeah, but me kind of pick it up.
All right, easy. Thank you guys.